Bismillahirrahmanirrahim. Our discussion about the probability distribution is going to start. Today, all of you are familiar with the concept of frequency distribution. This is basically an extension of the frequency distribution in the form of probability distribution. So what this presentation will contain? This presentation will contain the probability distribution, then expected value, which is basically the mean of the distribution. Expected value of x is the mean of the variable x. That can also be represented by mean of variable x or by simple x bar. We can write down, if it is a sample mean, it can be represented by x bar. If it is a population mean, then we can use the symbol mu or the mu x. Then we have to cover the binomial distribution, the Poisson distribution, and continuous distribution to be discussed. One of them is normal distribution. And then we have to describe some functions in Excel and SPSS to cover these distribution. In this course, we have to learn three more distribution, as I told you earlier. One of them is known as T distribution, the chi-square distribution, and F distribution. These are the three more continuous distribution which we have to discuss in detail. But the application or applications of these distribution are to be considered. Some details of properties of these distribution with their assumptions are also to be described. So that is the agenda of this presentation, and this is the agenda of the remaining course, in which we have to cover the applications of these three more distributions. Now, what is the probability distribution? We can extend the concept from a frequency distribution. All of you are familiar with the frequency distribution. In a frequency table, we have some values of the variable. Suppose these are 1, 2, 3, along with their frequencies. It is suppose 5, it is 10, it is 5, then total is 20. We can extend this concept to the relative frequencies. You are familiar with the relative frequencies as well. Relative frequency for first value is 5 by 20, and the second value is 10 by 20, and for the third value it is again 5 by 20. These relative frequencies have a sum of 1. So by perception, it is the probability. Relative frequency is the basically the proper probability of x is equal to 1. It is probability of x is equal to 2. It is probability of x. We can write down these probabilities as probability x is equal to 1. It is the relative frequency, which is 5 by 20, and so on. Probability x is equal to 2, it is 10 upon 20, and so on. And probability of x is equal to 3 is equal to 5 by 20. And by the values of these probabilities and by the values of these frequencies, you can determine the shape of the distribution. We have a height 5, then we have a height of 10, then again we have a height of 5. So it's looking like as a bell-shaped distribution. If someone is asking about the shape of this probability distribution, so you can see that the shape of this distribution is more or like symmetrical. We cannot say that it is exactly normal, but we can use the term of symmetrical distribution for it. So in simple, what the probability distribution is, Probability distribution is a table which comprised on all values of the variable along with their probabilities, such that the total of all probabilities is always be equal to 1 and none of the probability is negative. That is the very basic definition of a probability distribution. A probability distribution, in simple, I can write down, we have x and we have px, and it is 0.25, it is 0.5, it is 0.25, and it is 1 2 3, total of 1. Probability distribution can be written into three different forms. One of them is known as tabular form. This is the tabular form of a probability distribution. But we can also represent a probability distribution into another form. That form is called, this is tabular form. Other form is known as functional form. And the last one is the graphical form. Up to now, we have described the tabular form of a probability distribution. So in a tabular form of a probability distribution, we have two columns. In column 1, we have all values of the random variable. In column 2, we have all values of the corresponding values of the probabilities. It will have two conditions. The first condition is total of all probabilities is 1, and the second condition is sum of all probabilities is 1, and second condition is none of the probability is negative. Sum is 1 and all probabilities are positive. That's you can see from here. If we are writing the probability distribution in a function form, it is called probability mass function, PMF. The PMF is a term which is used for a function which can be, that function can represent a probability distribution. So a table can also be converted into the form of a function, or we can write down the function separately without the table. There is a possibility. And if it is in a graphical form, as I use this function, this graph, this is called probability histogram. So we can represent in a tabular form, in a graphical form, or in a function form. So these are the three different forms. I am giving you an example of function form later on in this presentation. Over this slide, you can see a problem. Die is biased, and the probability of even digit is twice as the probability of odd digit. Can anyone of you tell me the probability of having 3 dots when this die is rolled? If we have a die, then all values of random variable are 1 2 3 4 5 6, and probability of odd digit is twice as the probability of even digit. The odd digit, even digit is twice as the odd digit. Suppose the probability of odd digit is a, then it is a, then it is a, and the probability of even digit will be twice of a. So we have twice of a here, twice of a here, and twice of a here. As the sum of all probabilities is equal to 1, the total of all of these probabilities will be 9a. The 9a is equal to 1. And we have a is 1 upon 9. The probability distribution can be completed by just writing 1 upon 9 here and 2 upon 9 here and so on. It is 2 upon 9, and total will be 9 upon 9, it will be 1. So this is the complete probability distribution in this scenario. We can This is the complete distribution: 1 upon 9, 2 upon 9, and 9 upon 9. Sum of all of these probabilities will also be 1. If we are interested in a cumulative distribution, that can be completed by Fy, capital F, the symbol capital F used for cumulative distribution. For a cumulative distribution, you have to add these probabilities: 1 upon 9, 1 upon 9 and 2 upon 9 will be added, becomes 3 upon 9, 3 upon 9 and 1 upon 9 is added to 4 upon 9, and so on. This is 6 upon 9, and this is 7 upon 9, and the finally will be 9 upon 9. This is called cumulative probabilities. These are the cumulative probabilities. So we can extend the table by cumulative distribution, or dist is also known as distribution function. Why the cumulative distributions are formed? The reason is, if we are interested to compute the probability in between any two numbers, we can use this cumulative distribution for computing that. So that is the reason by which we can use or this cumulative function. Can any one of you tell me that this is the tabular form of this distribution? Can any one of you tell me how can I write down the function form of this problem? And small f is a representation of probability distribution, and capital F is a distribution function. This is cumulative distribution, this is simple distribution. And we have to define the limits of each part of these two functions. Here we have x is equal to 1, 3, 5, and here we have x is equal to, y is equal to, not x, sorry, because I represented the variable as y, not x. Y is equal to 2, 4, 6. This is the way of writing probability distribution into a function form. Similarly, if I am interested to write down the probability distribution in graph, so it is 1 by 9, then it will be 2 by 9, again 1 by 9, and 2 by 9, and so on. This is the graph, this probability histogram of the same distribution. It's 2 by 9. This is called the graphical form of the distribution. This is called the functional form of the distribution. This is called the tabular form of the distribution. And the random variable and the probability distribution. A random variable x or y or z is a function that assigns a single value but variable. Variable means what? It may have the different values at the different time instances for the each element of the sample space. So we have all possible values in a sample space. As I told you earlier, in probability theory, it is called sample space. In sampling theory, it is known as population. In set theory, it is known as universal set. And the probability distribution of a random variable is a table. If it is represented in a tabular form, that lists all possible values of the random variable and their associated probabilities. Here are some examples of the random variable. The return on an investment is in 1 year period is a random variable, because every investment have a different return on it. Suppose in 1 year we have 2000 investments, and every investment have a different return value. That is why we can say that it is a random variable. And the price of an equity is another example of the random variable. The number of customer entering a store is a discrete variable. It is a discrete variable, while the previous two are the continuous variable, because it may have in fractions, but the third one is a discrete variable, because the number of customer entering to the store or a number of users connected with a server in an internet, that is a discrete variable. The sales volume of a store on a particular day is another example of random variable. The turnover rate of your organization in the next year. So these are the few examples of random variables. Discrete random variable has jumps or measurable probability associated with each value of the a random variable. As I was saying, probability of x is equal to 1 was, suppose it was 1 by 9. So at each value of the random variable, we have associated probability. Here we do not have any single associated probability along with a single value of the random variable. In the case of continuous distribution, we have a concept of area, not the concept of a single value of the probability. Here we have the concept of probability, single value of the probability, but in the case of continuous distribution, we have here the function is fx, known as probability mass function. Here we have a function represented by fx, but we use the term density function instead of mass function. The density function is what? Density function is a, suppose this is a function and the entire density of this is the total area. So if we integrate, in case of the continuous distribution, we should have to integrate from the lower limit to the upper limit. If I integrate the function from lower limit to the upper limit, the total area will be 1. As I was saying that the total probability is 1 in case of discrete distribution. In case of continuous distribution, I can say that the total area is equal to 1. So the continuous variable have a concept of area, while the discrete function have a concept of sum. So that is the major difference between the two. Continuous variable cannot be represented in the form of table, because we cannot represent all values of the random variable, and we cannot represent all values associated with the values of the random variable. So that is not the case. So every time whenever the function is continuous, so we have a function, and every time whenever a variable is discrete, we can write down in a tabular form, we can write down in a function form, and so on. For a discrete distribution, sum is 1, all probabilities are greater than 1, and total of all probabilities is 1. It means probabilities are always in between 0 and 1. Minimum value of the probability is 0 and the maximum value of probability is 1. Now we have the another question. The actual purpose of writing a probability distribution is a utilization of the distribution in simulates. Simulation is what? If we represent a real scenario by a probability distribution, then the same scenario can be simulated for 1,000 times, 10,000 times, 20,000 times, and we can check the accuracy of that simulations. So model building, in model building, the simulation is very important. The simulation is basically a replication of a scenario by a model. That is basically a simulation. So if we know the probability model, we can simulate the probability model by using a statistical technique. So that is one application of the probability model. And the second is a prediction model can also be built by using this type of probability distribution. And we can generalize the real situation by mathematical functions. If we build a mathematical function for a specific situation, then we can use the prediction and forecasting by using that model. So these are 2 or 3 purposes of writing In a binomial experiment, the probability of success remains same from trial to trial. But here the probabilities are changing. In question number one, I have three answers, means the probability of correctly solving the question is 1 by 3. In question number 2, the probability is 1 by 4. In question number 3, it is 1 by 2. The probability is changing from question to question. So that is why we cannot say that it is a binomial model. Binomial model cannot be used here. The reason is probabilities of success is not constant from trial to trial in this case, as well as the probability of success is not constant from trial to trial in the second example. The reason is, if I took a blue ball from the bag, the probability of blue ball will becomes 1 upon 4 in the second attempt. In the first attempt, the probability of blue ball is 2 upon 5 if I am selecting one blue ball. In the second attempt, if I am again selecting a blue ball while previously a blue ball was selected, so the probability becomes 1 upon 4. The probability is changing from trial to trial. So that is why binomial model cannot be used in the second. Cumulative distribution can be represented by the graph. It is a step function because in a cumulative probabilities, the probabilities will be increasing in order. Suppose I have a 1, 2, 3 that the first example I gave you, the probability I used, it was uh, 0.25, it was 0.5, it was 0.25. So probability, these are the simple probabilities, but cumulative probabilities are capital F. Cumulative probabilities are what? Cumulative probabilities are 0.25, then 0.75 and 1. These are the cumulative probabilities. If you draw the cumulative probabilities, the graph will be like this. This is the step function. Sometimes the steps are constant, but other times the steps are not constant. Sometimes is a smaller step, is a smaller step, it is very smaller step, it is very smaller step, but this is a larger step, this is a larger step. The steps are smaller or larger depending on the values of the individual probabilities. Probabilities are 0.1, 0.2, 0.3 and so on. The cumulative are here and the step functions is there. Probability, cumulative probabilities can be help out to finding the area in between any two numbers. If we are interested to compute the area in between any two numbers, then this distribution will help us. Now the next topic is mean and variance of a probability distribution. Mean of a probability distribution can be computed by x and px are given to you. You have to construct one more column. That column is x times px. And sum of this column is the means. Sum of x times px is the mean of the distribution. So that is a very simple case. Finding the mean, when a table is given, you have to just multiply the variable with the probability and taking the sum of that. That sum is known as the mean of the distribution. Mean basically is a simple predictor. If you want to predict something, the mean can be used as a very basic predictor. So if the mean is very high, as well as if the standard deviation is very high, then we can say that the mean will not be a good predictor. So if we are covering or predicting by looking at the mean only, it is not a good way. But if we are predicting by looking at the mean and variance both, then the prediction will be better. If the mean is 50 and the variance is 0, what is the interpretation of this? So the two things are very important. Whenever we have a frequency distribution, as you learned previously, every time you are interested to compute the mean and variance of the frequency distribution. Here we have a probability distribution. From the probability distribution, still we are interested in the mean and the variance of the distribution, because expected value is what? Is the mean. We are expecting this value will be the future value. The mean value will be the future value. Our prediction will be accurate if in the case standard deviation is small. Our prediction will be less accurate if the standard deviation or the variance is high. This is a very basic prediction model. G, if anyone have query, you can ask. If we have a very high standard deviation in our data, or we have a very high variance in our data, then we should have to eliminate the outliers from the data. In the last lecture, I told you how to eliminate the outliers by a box plot. If some points are away from the right whisker, these are outliers. If some points are very smaller side away from the left whisker, then these are outliers. So if I eliminate these outliers and then compute the trimmed mean and the trimmed standard deviation, then will be a better predictor as compared to the prediction model, which is based on the data which contains outlier.
Plot.
Weighted mean. Weighted mean is an another option. It is my variable x, and I am computing the weights. Weights are what? How much utilization of this commodity in people have. Suppose monthly quantity used by a family of this item. It was, I think it was rice, and in a family 5 kg rice in a month is used. It was flour, and in a family 10 kg flour will be used in a month. It was pulses, and it is about 1 or 2 kg it is used. Similarly, on the average, how much honey in a family is used in a month? So it may be 0.25 or smaller than that on average. I'm talking about on average. So if I use X and W along with the computing the mean, then this mean will be referred to as weighted mean. So your weighted mean is what? Wx divided by summation W. This is known as weighted mean. So you can say that this may be the probability. The probability of this item is how much? So the actually answer is that I was discussing the computing the mean by using a probability model. So that is basically a weighted mean. The probability of this item is how much, the probability of this item is how much. So some items have a higher probability because they are commonly used, but some items, other items have a smaller probability because it is rarely used. So smaller probability and higher probability, sum of all probabilities will be 1. This is the another method of weighting. Now mean can be computed how? Mean can be computed as summation x time px divided by summation px will be 1. So I think so this formula and this formula are identical, but why there is no sum of all px in denominator we have here? Because sum of all px will always be equal to 1. So the weights are converted into the probabilities, and the sum of these probabilities will be equal to 1, and this mean, which is actually a weighted mean, will gives us a better predictor as compared to the mean used as unweighted. You can see x into px is the weighted mean, and definition was that the mean is also known as the expected value, is a random variable because it is basically multiplied by the probability. Means weights are the probability in this model, and the sum is 2.3, and we can say that the predicted value will be 2.3 if we have sixth value in this probability model. The variance can be computed in the same way, x minus mean whole square, expected value, or if I expand this expectation can be expanded by ex. Ex is basically the sum of x and px. So you have to weight by the probability. If you are interested in the expectation of y, then this will be y into py. If you are interested in the expected value of z square, then it will be equal to summation z square into pz. There will not be the pz square. It will be the z square time pz. It is known as the mean of z square. So here we have mean of x square. Here we have the square of the mean of x. This is the formula of variance. This is a simple version. You can remember the formula by this version. What is it? It is the mean of x square, and in subtraction we have square of the mean of x. The difference is known as the variance.
सर ये दोबारा बता देंगे दफा।
वेरिएंस का फार्मूला देखें आपने, मैं कुछ एलिमेंट्री लेवल पे जो वेरिएंस पढ़ा था वहां से, इफ इट इज अ सैंपल वेरिएंस देन वी हैव n-1 in denominator and numerator is same for the both of them, x minus mean whole square, x minus mean whole square divided by, these are the unexpanded form of the variance. If I expand this formula, then this will become summation x square upon n minus summation x upon n whole square. So you can recognize this as the, what is it? This is the mean of x square, as I am writing here, the mean of x square. What is this? This is the mean of x and the square of that. So all of you are familiar with this formula. This is the expanded form of the formula of variance. You can recognize this formula and this formula, both are identical, because what is it? It is the mean of x square. We are adding the x squares and then divided by n. It is known as mean of x square. So I am writing the mean by expected value, mean of x square. And what is it? This is the mean of x and a square of the mean of x. We can write down as a mean of x and a square of that. So you have both versions you have. You can use any of the version to compute the variance. What the Chebyshev inequality says, it will gives us the area or the percentage number of observations between mean minus standard deviation, 2 standard deviation and 3 standard deviation. Suppose this is mean and I subtracted the 2 standard deviation from mean, I will have the lower number, and mean plus 2 standard deviation, I will have a upper number. So I am interested in what? I am interested in finding the probability in between mean minus 2 sigma and mean plus 2 sigma. According to this theorem, this probability will be greater than or equal to 1 minus 1 upon k square. The value of k in this case is 2. This is the k. So if I put the k right hand side, 1 minus 1 upon 2 square, this will become 1 minus 1 upon 4. That is 3 upon 4. Probability is 0.75. In percentage, I can say that 75% observations will lie between the mean minus 2 sigma and mean plus 2 sigma. If I am interested to compute the probability in between mean minus 3 sigma and mean plus 3 sigma in my data, this is mu, mean plus 3 sigma, this is equal to, greater than equal to, not exactly equal to, 1 minus 1 upon 3 square, because right now the value of k is 3. So it is 1 minus 1 upon 9, 8 upon 9, 8 upon 9 in percentage. It is 88.9 or 0.888. That is the value of this. If I am computing the probability mean minus 4 sigma
सर ये जो
and
0.75 और पॉइंट
mean plus 4 sigma, this will be equal to, greater than equal to 1 minus 1 upon 4 square. This is equal to 1 minus 1 upon 16. So that is 15 upon 16. How much is it? 15 upon 16. You can have the number here. So we are going closer and closer to 1, or we are going closer and closer to the all values within my distribution. So this theorem is known as Chebyshev theorem, and Chebyshev theorem is valid for any set of data, for any shape of data. If your data is right skewed, then Chebyshev theorem is valid. If your data is left skewed, then Chebyshev theorem will also be hold. If your data is symmetrical, then Chebyshev theorem can also be applied. So Chebyshev theorem is defined for any observation, for any shape of the distribution, but it is not defined for k is equal to 1. If I put mean minus 1 sigma, mean plus 1 sigma, the right hand side becomes 1 minus 1 upon 1 square, that is 0. So k is greater than 1. In Chebyshev theorem, k should be greater than 1. Now these probabilities are shown at least means probability is greater than or equal to 75%, 89 lies within 1 standard, 2 standard deviation, 3 standard deviation, 4 standard deviation of mean. Of mean, actual concept is what? Mean minus 2 sigma, mean plus 2 sigma, mean minus 3 sigma, mean plus 3. These are basically the intervals. In these intervals, how much of your observations will lie, this number is greater than equal to, not equal to. These are at least, the word at least is used. At least there is no need to write down the greater than equal to, because the word at least is used here. I think it is correct. So you can have these probabilities, which are now coming to the next slide. You audit a transaction, it is either in compliance with the procedure or it is not. some business situations. You hire a person, that person is either a female or a male. You visit a customer, you lead to the sale or does not sale. You lower the price of a product, sale either increases or do not increases. One thing is common in all of these examples. Can you observe what that thing is? These are the Bernoulli trials. All of these four are Bernoulli trials, and these are the cases of the random variables. These situations are known as the Bernoulli trials. Now we have these two investment plans. We have the mean rate of return is 0.06 in investment A and 0.08. Here we have a higher return as compared to the mean, but the standard deviation is 0.02 and the standard deviation is 0.03. Which plan do you choose according? P is the probability of success, Q is the probability of failure, sum of P and Q is 1, and independently repeated Bernoulli trials make the binomial experiment. So what is the difference between the Bernoulli and the binomial? Repeated Bernoulli trials are making a binomial experiment. Suppose a coin is tossed 5 times. So n is equal to 5 and P is the probability of getting success. Suppose head is my success and the probability of getting head is 0.25, means the coin is biased. Then you are interested to find out probability of x is equal to 2. Probability of x is equal to 2 means what? We are interested to find out the 2 successes out of these 5 attempts. Total number of attempts are 5 and total number of successes in which we are interested to compute this probability is 2. So we can apply the binomial distribution if this probability remains fixed. Means first time when I toss this coin, the probability of success is 0.25 and the probability of failure is 0.75. When second time I toss the same coin, probabilities remain same, 0.25, 0.75. At the third attempt, the probability is 0.25. So every time we are using the same coin and the probability of success remains same from trial to trial and probability of failure remains same from trial to trial. But we are not saying that probability of success and probability of failure are equal in number. That may be equal if the coin is unbiased or fair, that may be equal, which will be the 0.5, but it is not the case in all the situations of the binomial distribution. So this can be computed by the formula NCX, P raised to the power X, and 1 minus P raised to the power N minus X. This is the function form of the binomial distribution. I am just connecting this formula with my slide number 1. On slide number 1, I told you a probability distribution can be represented in a tabular form, it can be represented in a function form or in a graphical form. So I am writing the function of the binomial distribution. We must have to define all values of the variable. It is not x, it is, I am just writing it as x because I wrote as a general formula. X is equal to x and your values of x are what? You may have success, 0 success, you may have 1 success, you may have 2 successes, 3, 4, 5 successes. If total coins are toss 5, then we have from 0 to 5. These are the values of the n is 5. You have to plug in the value of n here. You have to plug in the value of p. It is 0.25, it is 0.75. And x is what? X is changing from 0 to 5. If I plug 0 here, it is the probability of no success in 5 attempts. It means I toss 5 times, but head doesn't occur. I toss 5 times, If I am interested in probability x is equal to 5, meaning that if I toss 5 times, in all the 5 attempts I got success. So that is the probability of x is equal to 5. Slides in a fast way. The reason is we have to finish the presentation. We will try to finish this presentation today so that we will be able to consider the next lecture in the next week. And hopefully I will be there, inshallah, to conduct the lecture. Binomial can be written as bx and semicolon. You can write down, you can note down the difference. Here I have a semicolon, but at this point I have a comma. These two values are known as parameter. This is known as random variable. So very clear cut way of writing a binomial distribution. X is a random variable. These two values are known as the parameters of the binomial distribution. We first have to fix these two values of the, we first have to estimate. The appropriate term is estimate the value n and estimate the value p before using this model. And what the model is ncx p raised to the power x and 1 minus p raised to the power n minus x. And you should have to write down all values of x as well, because if the function is there, the limit must also be there. The values of x are what? 0, 1, 2, up to n. This is the formal description of a binomial distribution. Now we can have, these are the conditions. Now these are the different situations where we can apply the binomial distribution. The probability that 3 out of 8 tosses of a coin will result in a head. So we are interested in what? In this problem we are interested in b x is 3 with the semicolon, n is 8 because I'm interested in 8 tosses, and of a coin, and it is not decided here is a fair coin or an unfair coin. If it is not given, we should have to use the possibility of a fair coin. So this situation can be written as this, and this can be computed as 8c3 and 0.5 raised to 3, 1 minus 0.5 raised to n minus 3. N is 8, 8 minus 3, which is 5. If I calculate this number, is the answer of this probability. Now, the probability that Susan will beat the Shannon in 2 of the 3 tennis matches. So their success and failure. Success of Susan is the failure of Shannon, and the success of Shannon will be the defeat of the Susan. So interested in what? 2 of the 3 tennis matches means n is 3 and probability we are interested in 2 of means x is 2. We are interested in 2. But it is not decided here what is the success rate of Susan. It is not given here. So you can assume the both have the same rate of success. The 0.5 can be used. If it is not given, so you can skip. Just you can write down in a general form b x n and no value of p is there. Acha is ncx and p raised to the power x q raised to the power n minus x and the product of both, because this is the complete formula of binomial distribution with the limit. What is p, what is n, what is x is already defined. This is the tabular form of the distribution. So if I make a table, we have x, the values of x, we have the probabilities. Some of the probabilities are 1. So we can say that if you look at an expression which is q plus p raised to the power n, if you expand this by using the binomial expansion, then these all terms you will get. So it is nothing. It is just an expansion of q plus p raised to the power n, because q and p, if we add q and p, this is 1. So actually it is 1 raised to the power n, and it is equal to 1. So you can see that the sum of all of these probabilities will be equal to 1 here. These are the different values of the probabilities. You can see the sum is 1. Finding the probabilities, the same problem is described here. This is very important. If you can calculate the binomial probabilities by using uh, this, by using the probability table, if the probability table is cumulative, so you can calculate the probability by
Sir,
differences. As this table is given as a
excuse me,
cumulative.
sir.
Yes.
Sir, if you don't mind.
When x is equal to 4, the probability is 0.99, meaning that probability x is less than equal to 4. So it means this table is a cumulative table. We can compute the probability 3 by f3 minus f2. What is the meaning of capital F3? Meaning of F3 is this probability 0.9133. This is F3. F3. And what is F2? F2 is here. This is F2. 0.683. If I subtract
सर ये वैल्यूज है ना 0.50 वाली लाइन की हैं आई थिंक वो
yes,
गलत मार्क हुआ हुआ है
you are right. ये मार्क गलत हुआ है और ये वैल्यूज जो हैं वो यहाँ की हैं 0.813 ये वाली हैं.
एफ ऑफ एच में भी जो लिखी हुई है वो सारी 0.5 वाली हैं
These are the two values 0.813 and zero point 0.5. But if the table is not cumulative, you have to add the probabilities instead of subtracting them. Suppose I am interested to find out the probability of x is equal to greater than 2 and less than 4. And I do not have a cumulative table. So greater than 2 and less than 4 means what? Probability of 3 itself. So if the table is not cumulative, this probability will directly be available into the table. So you should have to think whether the table is a cumulative table or is a simple table. If it is a cumulative table, you have to take the decision according to that. If it is a simple table, then you can find out the probability directly. Like this is the simple probability. 0.03, 0.15, 0.33, 0.31. If I add these cumulatively, then we have these numbers. So this is cumulative, this is simple. Now you can find out these probabilities. I am just skipping these. And a state senator believe that 25% of all senators on the finance committee will strongly support the tax proposal she wishes to advance. Suppose that this belief is correct and 5 senators are approached at random. What is the probability that at least one of the 5 will strongly support the proposal? What is the probability that the majority of the 5 will strongly support the proposal? Is this a binomial experiment or not? Is this a cumulative table or a simple table?
सिंपल लग रहा है.
It is simple table
सिंपल
because in a cumulative table, the last line should have 1 or 0.999 all over there. The last line will have either 0.999 or it is 1. So in my last line, it is not 9.999 or it is not 1. It is very small probabilities we have. These are the simple probabilities. So what was the parameter in the last problem? In the last problem, P was 0.25 and N was 5 senators. And in what I was interested? I was interested in probability X is greater than equal to 1. So the P is 0.25, it is. And I am interested only in 5. I am not interested in these values. I am interested only in last value. I am just skipping it because my interest is only in these numbers. Only in these numbers. Because my value of n is 5. X are what? X are 1, 0, 1, 2, 3, 4, 5, and I am interested to add all probabilities from this can be written as summation of probabilities X n is 5, P is 0.25. And directly you can obtain this number X is equal to 1 to 5. So you have to add all these numbers. If I add all of the last 5 numbers, this will be the answer. Otherwise, I have to subtract 0.237 from 1. If I subtract 0.237 from 1, then the answer will be there. As I solved the problem by 1 minus probability, this is the probability of x is equal to 0, 0.237. So that the same probability as I was calculating on the slide, this is here. So that is the difference between the cumulative table and a simple table. You can use any of the table, which one is available. But in exams, I generally use this table. This table is available in Neil Levy's book. And if you are in physical exam phase, so this table will be provided to you in the physical exams. The binomial table is available for values of values up to 20. If your value of n is greater than 20, we have the two options. One of them is you can switch to the Poisson distribution, which is the next topic in my presentation, or you can move to the normal distribution if I am moving to the continuous distribution. The two options you have. Normal distribution. We call it as a normal approximation to the binomial distribution or a Poisson approximation to the binomial distribution. The binomial distribution can be switched to the Poisson model or it can be switched to the normal model depending on the scenario. What the scenario is? Binomial, and scenario is if P and Q are very distant to each other, then we should prefer to use Poisson approximation. If P and Q are closer, so we prefer to use normal approximation. So we switch the binomial to the normal distribution if P n is greater than 20 and P and Q are closer to each other. This is called normal approximation to the binomial distribution. And if P and Q are very distant to each other, suppose P is 0.0001, then Q will be 0.999. In that case, we prefer to use a Poisson model. So we will discuss the binomial Poisson and the normal model in the rest of this presentation.
सर आपकी आवाज नहीं आ रही है
सर म्यूट पे
The mean of the distribution is NP The variance of the distribution is n times p times q, and standard deviation is under root npq. Similarly, if we are interested to compute the mean and standard deviation, if the coin is tossed and the probability of head is 0.3 and n is 5, then 5 multiplied by zero point 0.3 is the mean, and 5 multiplied by zero point 0.3 multiplied by 0.7 will be the variance, and similarly the standard deviation will be the root of that. There is a simple way to compute this. Now draw the following binomial distribution using Excel. How can we draw these distribution into the Excel? So I will demonstrate one example here. Suppose we are interested in this one, bx 4.1. bx 4.1 means what? N is 0.4 and p is 0.1 and q is 0.9. X is not defined means different values of x we can use. If n is equal to 4, the values of x will start from 0 and goes up to 4. So 0 to 4, these are the values of different values of x. So I am changing the share. In Excel, in the first column will be x. So what values of x there was? 0, 1, 2, 3, 4. What was the value of p? It was, I think,
Point 3.
it was 0.1. In the first case, it was zero point 0.1. So if p is 0.1, here we have to write down the formula of the binomial distribution. BIN. We have the different functions here. One of them is binom dist. Can you see? I'm just zooming it.
Yes, sir.
Magnifier. Now you can see it clearly. Binom dist. Binom dist return the individual term binomial distribution. Binom dist in a range. Right? In a range, you have to define the random numbers. Binomial inverse. Here, the probabilities will be given and the x will be the output. So these are the different options we have. I am just using binom dist. In my case, the number s. The number s is basically the x basically. X is defined by this address x, and the number of trials are, I think it was 4, and the probability was what? Probability was
Point one.
point 0.1. So you have to use 0.1 as a value of p. Then the last parameter contains true or false. If you want to write down the cumulative distribution, use true. If you want to write down the simple probability mass function, it is false. It's totally on you what sort of distribution you want to generate, whether the cumulative or simple one. I'm just drawing simple one. So I'm using false here and press enter. 0.6561. This can be generated for the rest of the values. So you can see the different values of the probabilities. We can have that. Oh, I'm just stopping the magnifier because it's causing problem. Now you can clearly see this is px, probability of x. This table is known as the probability distribution of x. In this should be 1. Sum of these numbers is 1. You can draw the graph by just selecting these numbers. Now select these numbers because it was required. You have to draw the graph. Insert. Cancel. Save. Insert. For one variable, I have to draw this. This is the graph. So you can see that it was for p is equal to 0.1. If p is smaller than 0.5, you have a right skewed distribution. If your p and q are closer to each other, then you have a symmetrical distribution. If your value of p is greater than 0.5, you have a negative distribution. So in a simple word, you can generate the table by different values of x. How many values of x you have to generate is depend on your value of n defined in the problem. You have, if your n is 4, you have to write down 0 to 4. If your value of n is 10, you have to write down from 0 to 10. Then you can calculate the probability by binomial model, binom dist distribution. And you have x, then n, then 0.1 is the value of p, and then false means this is not cumulative. If you want to generate a cumulative table, then it will be true. You can generate the different probabilities by this way. Now I'm showing you the different tables which is generated for this distribution. You can see these graphs here. These are the different graphs. It is for p is equal to 0.1, it is p is equal to 0.3, and p is equal to 0.5. You can see that as p is increasing, your value, the graph becomes symmetrical. When it is 0.5, it is symmetrical, or just like as a non-skewed distribution. And as n is increasing, you can see that the rectangles width are smaller. So we have a smaller rectangle when n is equal to 20. We cannot have the more than 20, the value of n, because binomial is used for the 20 values. So if p is more than 0.5, like 0.6, 0.7, 0.8, the shape of the distribution will becomes the negative skewed distribution. So if p is smaller than 0.5, it is a right skewed distribution. If it is greater than 0.5, it is a negative skewed distribution. A limit, and that limit is what? N tends to infinity. Then binomial model will be comes into the another function. That function is known as the Poisson model. This Poisson model. So as I told you, binomial and Poisson, all the conditions are same, except only the one condition, and that condition is what? Your value of n is above 20. If your value of n is above 20, you can use the Poisson model in that. This is the Poisson model. The Poisson probability distribution is useful for determining the probability of the number of occurrences over a given period of times. All the situation where binomial was used, we can use Poisson model over there. The reason is, for large number of n, instead of using combinatorials, we have to approximate this by Poisson distribution. This is the problem of a distribution. We have to solve it. Product is produced which is defective, and there may be infinite number of the product produced in one day which are defective. So these are the all possible values of the random variable x. But we are interested only on a given date. There are 12 products. So we are interested in probability of x is equal to 12. Probability x is equal to 12 means we are interested in computing the 12 defective products are produced in a specific day. We are interested to compute this probability. So by a Poisson model, it is e raised to the power mean raised to the power x is 12 in this case, divided by x factorial, it is 12 factorial. If I solve this expression, we will get the probability of 12 defective. In part B, you have to calculate the at least 3 defective product. At least 3 defective product means it is either 3 or more than 3. It is 3 or more than 3. But more than 3, we cannot calculate more than 3, because more than 3 means what? 3 or 4 or 5 or 6 or up to infinity. So we cannot add up to infinity. So we should have to convert it into 1 minus probability x is less than 3. Or we can say it is less than equal to 2. So I am computing 1 minus probability of 0, 1 and 2 and 2. How the probability of 0 is computed? So this is equal to 1 minus probability of 0 is e raised to the power minus 21. So I am taking e raised to the power minus 21 as common, because it will be in all the three terms. 21, not 12. This is e raised to the power 21. You have to compute it in one time. Divided by 21 factorial. No, it will be changed from term to term. So it is not common. We have to change it from term to term. This will be equal to, now we have 21 raised to the power 0 by 0 factorial plus 21 raised to the power 1, 21 raised to the power 1 upon 1 factorial plus 21 raised to the power 2 upon 2 factorial. You have to add last three terms and then multiply the sum by e raised to the power minus 21, then subtract this total by from 1. You will get the correct answer of x is greater than 3 defective products.